So for those who were able to make it today, I appreciate you coming out. For those who've never met me, my name is Chalmer. Myself and my colleague Ria and several others, we run PyHawaii. We've been doing PyHawaii now since June 13 of last year. We're up to about 203 members total. Not that any of them are here today now that we're in a new place. But hopefully that'll change over time as people get ready and get used to the new location, etc. We are initiating a data analysis series. It's going to be about 7 sessions long, give or take. I might make it a little longer if I come up with some more stuff. The first session is going to cover a tool called Numpy. It's used for doing numerical analysis. It's a combination basically of the talents of 2 different previous tools, one of which was numeric. From there, we're going to move forward into using another tool called Pandas. It's used for not just numeric analysis, but analysis of all sorts, including non-numeric data. That'll be about 6 sessions worth of stuff. Pandas is pretty robust. Some of the things that we learned tonight in the Numpy conversation will apply to how you use data matrices or data frames in Pandas. So, real quick, for those who haven't heard, if you want to log on to the Wi-Fi, you go to the events SSID. It will then ask you for an email address. If you use guest@eolani.org, it'll work for you. The password is just guest. In terms of the pertinence for tonight's agenda, for those who are not in the room, I'm pointing right now. There are bathrooms over there. For those of you out there in the real world who are watching this, you have to figure out where your own bathrooms are. We do have Wi-Fi. For those in the real world, you can't see it, but I've got a little kind of bi-directional arrow pointing to either one of these 2 things because I don't know which is most important to certain folks. Some people rely on more than one of those more than the other. In terms of the rules for this space, we are guests of the Iolani School. They have very kindly donated the use of this space, so we ask that folks treat the space appropriately in several ways. Understand that in some cases there are going to be children kind of wandering around doing different things school-related, so keep language to a level that's appropriate for kids. And 2, when we kind of leave, we want to clean up and leave the space the way we got it when we arrived. There is a live stream. If anybody wanted to test it out, I do have the URL for that up on the screen. If everything goes well, this will be recorded and it'll be stored on YouTube for posterity's sake. So you can point your friends and family to it. Depending on how well this turns out, you might point to your friends and people you don't like to it. We'll see. Schedule and time for this. We're trying a new time, partly because of the limitations in the Iolani School schedule. So we're going to shift things back to 5 o'clock. We're going to see how well that works out. We're going to be doing PyHawaii sessions twice a month instead of 4 times a month, partly because of demands on our own time and partly in the hopes that we can produce content that might be a little more useful or meaningful if we have a bit more time to prepare some of it. And with that, I'm going to dive into Numpy, and then we'll talk a little bit about next steps and where we're going to go from there. So before I sit down and start working on stuff, does anybody have any questions? Nope. For those who might be out there in the real world, we do have a chat room. If you go to the YouTube site, you should be able to get into our Google Hangouts. And with the Google Hangouts, if you have a question, you can send it to me via chat. Alrighty, let's see where we go. So what I often do is I'll create a demo script that walks us through a series of steps. It basically is a long script that's got stop points built into it. And I tell the script to run, it'll go through the first stop point, and then we can talk about what we see. It's kind of like PowerPoint, but it allows me some interactivity. Halfway through, I can immediately jump back onto the command line without kind of switching back and forth from slide to command line, slide to command line. So we'll see how it works. Run demo batch numpy. All right. And so the first quote-unquote slide, it's on the screen. Numpy as a package is used predominantly for scientific computing, mainly focused on numbers, right? It helps you by providing multi-dimensional arrays or matrices. And by multi-dimensional, you can get lots of dimensions. You can have a single dimension like a list. You can have two-dimensional array like a spreadsheet. You can have three-dimensional array, which might be multiple pages in a spreadsheet, for example, or it might represent items, for example, like the elements in a 3x3 cube. Other things that Numpy brings to the table are this collection of functions that are built in, and they provide you with operations that might be mathematical or logical. They will provide you with capabilities like doing basic Fourier transforms. You can do some basic linear algebra, do some statistics, etc. And it makes things very easy. So let's take a look. All right. A couple things to note about Numpy. The arrays that you build with Numpy are a fixed size. If you're used to using lists in Python, lists can change in size. With Numpy, because of the way they've built them in the background, they are fixed in size. If you need to change the size of a Numpy array, basically you have to make a brand new one from scratch. Copy your original data and increase the size. In almost every case, except for kind of one that we're not going to touch on, the elements in a Numpy array have to be the same type of object. Again, if you're used to using lists in Python, I could have, for example, a list with a name, maybe a string, have another string, and then I could have an integer, say a person's age. In Numpy, all the items have to be the same. Maybe they're all floats or they're all integers. The underlying mechanics behind a Numpy array allow for vector mathematics, which basically means you can change all of the elements in an array essentially at once without doing a for loop through them. I could, for example, take a list of items. Say I've got a bunch of numbers in Python. I'd say, let me multiply each item in this list by 2. And I'd say for item in list, multiply item by 2, and you dump it back into the original list in some way. With Numpy, instead of having that for loop, you just say multiply the array by 2, and it will, on your behalf, go through and multiply each item. And we'll see some examples of that. This vector mathematics has, in certain cases, some very significant performance increases, and in some cases, maybe not so much. And under the hood, a lot of Python scientific and mathematics libraries use Numpy to do what they do. All right. I've got a script that I'd like to run. Let me make sure the name of the script. All right, so run the comparison script. What's going to happen, and I'm not going to show the mechanics of it, all the details of how I wrote the script. But what I'm going to do is I'm going to take two lists, and I think I multiply the values of each item in the two lists against each other. And then I'm going to do the exact same thing with two Numpy vectors. And we're going to count how many microseconds it takes to do this calculation for a short list, a longer list, and then a very long list. And we'll compare that with a short Numpy vector, a medium Numpy vector, and a long Numpy vector. And in both cases, the number of elements in the list versus the vector are the same. And we'll see how many microseconds it takes to do these things. All right. So on the screen, I've got, in my Numpy vector, I had 100 items, for example, and it took 28 microseconds to do this multiplication of two 100-item vectors against each other. With a Python list, it took me 92 microseconds to do that. With a Numpy array with 1,000 items times another Numpy array of 1,000 items, it only took 8 microseconds, whereas to do it on a list, it took 422 microseconds. So you can see some very significant kind of performance hits if you do this using just lists. So if you have to do lots of heavy-duty calculations, Numpy in many cases can definitely save you a lot of energy and time under the hood. As we go along, if anybody's got any questions, just hit me up. Feel free to interrupt. It's all good. He gets grouchy when people interrupt him, but I don't. By the way, that's my son. All right. To get started with Numpy, because it is an external library, you import it. So here we import Numpy. A lot of people choose to give it an alias. So I'm going to say import it as NP. Later on, if I want to refer to the Numpy library, I can just type NP and I can refer to a method or a function that's inside it. We're going to start off with something easy. I'm going to create an array range, and I'm going to ask it to provide 42 items. It's going to start with 0, just like Python does when you use the range function in Python, and it'll go all the way up to 41, and we'll have it print on the screen. You notice it clearly calls itself as an array, even though it kind of looks like a list. That's to help you visually identify that you're not playing with a Python list. And as we expected, it started at 0, went up to 41. For those who aren't familiar with range in Python, if you tell it, for example, 42, it goes up to, but does not include the last item. Now that I've made A, and it's an array, and it's got 42 elements in it, I can change its shape. At the moment, it looks a lot like it's a list. It's a single dimension. In this case, I'm going to tell it to reshape itself. I'm going to ask it, I think, to have 6 rows and 7 columns. And we'll call it a new name. We'll say A1 and print it out. And you see it's got 6 rows, 7 columns. Each row is identified by a set of its own brackets, and the entire matrix is encapsulated with another set of brackets. I'll try and highlight that with my cursor if I can. So the first row has got a set of brackets on either end. It's separated from the second row by a comma, and then the entire matrix is encapsulated by these outer brackets.
Also,
Sure.
another thing is for the single-digit numbers, they have a space there so that it lines up properly.
Yep, they do have pretty printing to help things line themselves up nicely. All right. Once you've made an array, you can ask Numpy for details about it. In this case, I'm going to ask it for about 6 different details. The first detail I'm going to ask for is tell me how many dimensions it has. Ignore the misspelling of the word dimensions. That was probably done at the crack of dawn. But you can say a1.ndim, and it'll tell you how many dimensions. In this case, it should say something like 2 dimensions. I can ask it what the shape is, and it'll give me a response. It'll say there's 6 rows, 7 columns. I can ask it the size of the array, and this counts individually how many elements there are. So it should come back and say something like there's about 42 items in the array. I'll ask it what kind of data type is this? Are these integers? Are they floats? If they are integers, what type of integer are they? How many bits are used to represent each value of the integer? And lastly, I can ask it, how many bits or how many bytes are in each element. In this case, I think it's probably going to say something like 8. And then I can say, what is this type of object? And we'll see it. All right. So sure enough, 2 dimensions, gives me my shape, all the things I expect. We see the data type in this case happens to be an integer with 64 bits. So it's actually kind of a large value. You can set the type of data type you want to use. Having all your integers stored in 64 bits takes up a lot of space, memory-wise, especially if you're dealing with only small numbers. So you can fine-tune some of these things. All right. Any questions so far?
What does a 4-dimensional array look like?
That's bordering on time, space, mechanics, and we're not going to deal with that today. I will show you a couple examples of what multi-dimensional arrays look like. We'll see at least, I think, a 3-dimensional array, and you can extrapolate from there.
I extrapolated 2 from 3. And
Sure.
Four.
Gotcha. All right. I showed you how to make an array out of the arrange function. You can also make an array out of your own data. In this case, I want to create an array. I want it to have 3 items. These happen to be floats. They've got a decimal in them. I put them into this using a list. You could use a tuple. And when I say list, I'm actually embedding a list in here. I can tell it's a list because it's got the brackets. If you wanted a tuple, you could do that. If you have other sequential data types, you can use a variety of them. It's pretty good at pulling individual elements out of sequences. So I'm going to say, all right, make an array and include these 3 things. They all happen to be floats. So Lord willing, it should understand that automatically, and it should create an array that has floats. So I'm then going to ask it, I'm going to say, tell me what the data type is for this array F. And then I'll ask it, show me what F looks like. And it says F is composed of floats, and there's 64-bit floats, which is probably pretty big if I only have 2 decimals. And then it shows the array. A couple things to note. even though I typed in 1.0 in terms of screen space, in many cases it'll trim off that following 0, so don't be surprised by that. All right, so next, I'm going to make a 2-dimensional array. I'm going to have 2 rows. The first row is going to look a lot like the first one that I had, and then the second row, again, is composed of a bunch of floats. And we'll ask it what a 2-dimensional array looks like, and we see that there. Again, it does its best to try and line things up so that the array comes out in a pretty way, makes it easier for you to look at your data and assess it. And it still drops that 0. All right. This case, I'm going to make another array. It's again going to be 2-dimensional. I'm ditching that float thing, and I'm going to specifically tell it, I want this to be an 8-bit integer. This is going to save a little space in memory. And then I'm going to, once I've made this 8-bit integer array, I'm going to ask it, tell me the data type just to kind of confirm that it actually worked out. A couple things to note in this case. When you tell it the type of array or type of data, if you are using a regular Python data type, like a straight up int or straight up float, you can type int, you can type float. If you are using a Numpy style of data type, like an 8-bit integer or a 32-bit integer, you have to put it in the quotes. Right? And that tripped me up quite a bit first few times I tried this. So I created this array. I'm going to ask my Python to show it to me. It says, hey, yes, we've got this array. All right. NumPy's got some built-in shortcuts to help you produce arrays quickly. Sometimes you want to populate an array. You want to have the complete array built so that way you can then drop data into particular spots. And what if you want to start with all of your values set by default to 0, and then you will kind of populate them as you get more data? It's got a built-in zeros function which allows you to make arrays. In this case, I'm going to make 4 rows, 5 columns, and there you go. Similarly, if you wanted to populate it with 1s up front, you can do that. Here I made a 3-dimensional array. It's got, you can kind of picture it in your head as maybe like 2 sheets of a spreadsheet, with each sheet having 3 rows and 12 columns. And one spreadsheet's kind of nested in front of the other. And if you wanted to go, like my son asked about, to 4 dimensions, then it gets a lot crazier. I haven't wrapped my head around it, so we're going to skip that for now. Okay. You can also make an array that is called empty. But it's not really empty. It's full of random values. In some cases, they will look like zeros. In some cases, they will look like values that are very close to 0, but they are indeed random. How they populate it is based a little bit on what is in your memory to help it kind of make that population decision. And I will say that it was very frustrating and confusing to me when I first started playing with it, because sometimes I would run this command and it would show me a bunch of zeros. I would run the command a second time and it would show me a bunch of random values. I have no idea what we're going to see now. Could be zeros, could be random. Find out. And look at that. It happens to be random. All right. I'll show you guys later how you can change those values kind of on the fly, set certain values to turn on, turn off, etc. We talked about array ranges. There's a lot of flexibility to make array ranges how you want them. In this case, I'm going to create an array, and it's going to have values starting at 2. It's going to go all the way up to 20, but it's going to skip by 3. And it will not go up. It'll go up 2, but not including 20. Sorry. So from 2 up 2, but not including 20, and it'll skip by 3. And there you go. Starts at 2. Goes up to 17. You can't go to 20 because that's how Python is in most cases. Now this is kind of fun. In a regular Python range, you can set it to skip by integers. NumPy takes it a step further. You can tell it to skip by fractional amounts. In this case, I'm going to have it skip by a value of 0.3. So it's still going to go from 2 up to 20, but it's going to skip by 0.3. And we see 2, 2.3, 2.6, 2.9, 3.2. If you know a specific amount you want to skip by, that works fine. If, on the other hand, you want to make an array that's got a certain number of values, say I want to have 61 values, I want to start from here and go up to something, you do not have to calculate your spacing. In this case, by using the linspace function, I can tell it start at 2, go up to 20, and give me 61 values back. And it'll figure out what those should be. And there you go. With arrays, if they are the same size, the mathematics for them is very easy. In this case, I'm going to make a couple of arrays. The first one is going to be 4 values, 7, 13, 42, and 99. The second one is just going to be a bunch of 1s. I'm going to have it make an array that's got 4 spots in it, and each spot has a 1 in it. And then I'm going to say, take my first array and subtract the second array from it, and it will automatically go, all right, 7 minus 1, 13 minus 1, 42 minus 1, 99 minus 1. But I don't have to do any for loops. I don't have to say, find the first value, subtract it from the first value. I don't have to do any of that crazy. And then similarly, I'm going to follow along, and I'm going to say, all right, take the first array and add that second array to it. I'm going to spit out the results. The print statements are just so that when it spits out to the screen, we can kind of highlight which one of those things I'm printing. So we'll see the original array, the second array, and then we'll see the maths. Right? So sure enough, I got an array that I wanted. This one is a bunch of 1s, and then it does the math. 7 minus 1, 8, or 7 plus 1. And that's pretty cool. Before I learned about Numpy and some of these features, I would write for loops for every item in here, find every item in there, and do the math for me, and it was all crazy. Okay. All right. So here's a test for you guys. I'm going to make an array, X. How many rows and how many columns do we expect to get back from this? For X.
Yes.
Exactly, right? Sweet. So we'll have 1 row, 2 rows for X. Each row is going to have 1, 2 columns. So we're going to have a 2 by 2 matrix. Y should be roughly the same. If I multiply X by Y, what do we think we might get back?
A 4-dimensional matrix?
Yes.
For those in the etherlands, yet again, my son has brought up 4th dimensional matrices. I can tell this is going to be a running theme. All right. You may have to walk home, son. All right. So what happens when you multiply a matrix? Any guesses? Yeah. We're going to take the first value in the first row and multiply it by the first value in the first row of the other matrix. So I'm going to take a 3 and multiply it by a 7. I'm going to take 4 and multiply it by an 8.
So it's not matrix.
Let's see what we get. So I get it's not dot products.
Oh, it's a matrix multiplication.
All right. So I get a 3 times a 7 gives me a 21. 4 times 8 gives me a 32. We're going to see dot products in a little bit, and we'll see why we might use them. But again, if you were going to use for loops, you'd have to say, for the first row, find the first element. Find the other first row and first element, and multiply this and store it in some sort of output. This makes it very easy to do different types of vector mathematics. All right. Okay. There is a mathematical construct called the dot product. Numpy handles that quite well. It allows you to take the values of one matrix and multiply them in a particular manner against the values of another matrix and perform kind of some summing. So we'll talk about this a little bit. The first matrix happens to be a set of prices. I have 3 things I sell in my deli. I sell a chicken sandwich, I sell a veggie sandwich, and I sell some sort of pork sandwich. So the chicken sandwich is $3.49. The veggie sandwich is $4.49, and the pork sandwich is $3.99. Okay. I have a record of my sales, and I keep a record of my sales across the week. The first row is Monday through Friday, and how many chicken sandwiches I sold. The second row is Monday through Friday, and how many veggie sandwiches I sold. And the last row is Monday through Friday, and how many pork sandwiches I sold. So what I want to find out is how much money did I make on Monday? So I want to take the 5 chicken sandwiches sold on Monday, the 10 veggie sandwiches sold on Monday, and the 7 pork sandwiches sold on Monday. And I'll multiply them by their respective prices. And then I want to go and do the exact same process for Tuesday. And I want to end up with 5 values. How much money I made on Monday, how much money I made on Tuesday. And that's what the dot product does for you. If you want a more in-depth understanding what dot products do, I will leave that up to a friend of mine. You might know him. His name's Google. He'll help you out. But ultimately what we'll get here is we'll get $3.49 times 5. I'm going to add that to $4.49 times 10. And I'm going to add that to $3.99 times 7. And that will give me everything I earned on Monday. And we'll do the same thing for output 2. All right. So another thing to notice, once I've made the array prices, it has a lot of built-in functions, and I will show you some examples of these. One of those built-in functions is the dot function. And I provide it with an argument or a parameter. I say, hey, take the prices, do a dot product against sales. And let's see what we get. We get 5 values, and this is how much money I made. Obviously, Wednesday is my big ticket day. It's when I make my most money. Okay. So let's look at a couple of these things. We're going to start off with the Numpy library. I'm going to look at all of the methods that are in the Numpy library, and there's a ton of them. So if I hit NP and I hit the dot and then I hit the tab key, you guys are going to see all the different methods and items that are available to me. And there's a slew of them. So many that they've rolled up off the screen, right? So we'll start with the lowercase a's. There's an abs function to check for the absolute values of items that are in your array. There are ways to check for the maximum and minimum values. There's ways to calculate gradients. There's ways to look at the hypotenuse of values that are stored in arrays. You can create histograms of the values that are in your array, etc. We are not going to go through all of these. We don't have the time. The gist of this is that there's lots of things that are built into NumPy that will help you save time, so you don't have to write these functions yourself. You go, well, how do I learn more about these things? How do I figure out what I can do with some of these things? So let's go look at that. If I want to know more about the arrange function, I can type np.arrange, and I can ask a question about it. I put the question mark in, and I hit enter, and it brings back the help file for that thing, and I can learn about it. For those who aren't familiar with the Python help files, sometimes they take a little bit of getting used to. They'll use some terminology maybe you're not familiar with. They have some shortcut syntax that they use to represent certain things. I'll give you an example. In the arrange function, and I'm trying to highlight it on the screen, you'll see there's a parentheses, and there's some brackets in there, and there's some words. They have a word stop, and it is not inside brackets. That item is required. You have to put a stop point for your range. But the items that are in brackets are all optional. You can have a start and a stop if you want to, but you do not have to have a start. If you want to start, or if you want to leave the start out, it will default to something. And hopefully the help message will tell you where it defaults to. So if I skim down and I look at the parameters for the start, it tells me a couple things. A, it has to be a number. B, it's optional. And then it says this is the start of your interval. Your interval will include that value. And it says, hey, by the way, the default value is 0. Okay. You notice that the step is also in brackets. A couple things to note. The commas are also in the brackets. That is indicative that the commas are required if and only if you're going to use that item. And again, we can look down at the step. It says, hey, this is the space in between values, and it kind of spells it out for you. All right. Okay. To get out of this, you hit the Q, and it brings you back to your command prompt. So you can play again. All right. And for the record, I'm using a tool called IPython. IPython is a scientific wrapper that's designed to help people do analyses and data manipulation. But lots of folks, even folks who don't do data analysis, use IPython. And it's got some built-in helpers. One of the things is it's got this very nice tab completion. So I type np dot, and if I hit the tab key, so I press tab key now, it spits out all of those things that are available to me. If I were to type in 1 or 2 characters like np.di, and I press the tab key again, it'll show me only those methods that started with di. So IPython comes with this tab completion built in. It makes things nice. It also comes in, or comes built in with that very helpful syntax of using the question mark. If you were using a regular Python interpreter and you wanted to get help on NP arrange, you could type help bracket np dot arrange, close parentheses, and it'll spit out the same help. But it's not as fast as using just the question mark, the way IPython gives you. If folks have questions about IPython, I can walk you through some of that kind of after the conversation's over. All right. Let's see. Crud. I'm going to run this, but we're going to come back to it. I wanted to show you something different. Let's see. So prices. All right. I mentioned that you can go into the Numpy library and see all the things that are available to you in the Numpy library. Each and every array has a different set of functions and methods that are built into it. Sometimes there'll be a little bit of overlap between the Numpy library's available functions or methods and the ones that are available for a particular item. So we've got that array that we made earlier, prices. If I hit the dot, and again, I hit tab complete, you'll see that it gives me certain options. I can do certain things with it. Notice that dot is one of the things that I can do with an array. I can set the type of data that's in the array. I can change the shape of the array. I can write it out to a file, or I can write it out to a list. I can resize it and change whether it's 2 rows with 6 items to 3 rows with 4 items. I can check for the maximum value in my array. I can check for the mean value, the minimum value. I can sort the items in my array if I want to. They have a thing called squeeze where you can kind of condense the values in the array in certain ways. Lots of cool things you can do. And again, all of these are available to you, and you can ask Python, well, tell me a little bit more about that. So for example, let's do reshape, figure out what that means. All right. It says, hey, it will give you back an array that contains the exact same data, but with a new shape. If I go look in the Numpy library for reshape, it gives me a little bit more details and tells me how you tell it to create a shape. We'll see that in a couple minutes, so don't fret. All right, before I go any further, what questions might you have about what we've seen so far or about the help? Good enough. All right. Numpy comes with a random library. It makes random values, and there's a slew of different ways you can do that. You can say just pick random numbers between value x and value y. You can say pick random integers between value x and value y. This case, I'm going to go into the NumPy's library for random numbers and ask for random, and I'm going to tell it to produce, I think, 3 rows by 4 columns. And then it'll print it out once we made it. And then I'm going to say, all right, look in that array and give me the maximum value, the minimum value, and give me the sum of the items in the array. So let's see what we get. All right. And notice in this case, it gave me a bunch of random values between 0 and 1. They're all positive. The maximum was 0.9. The minimum was 0.16. And then when it does this fancy math and adds them all up, we get something like 5.7. But what if you don't want, and notice also, even though I have 3 rows and 4 columns, it didn't care. When I asked it for the max, it found the biggest value in the entire matrix, regardless of what row it fell in. What if you don't want that? What if you want to know what's the biggest value in each of the rows, or what's the biggest value in each of the columns? There's ways to do that. So I'm going to change I'm going to create an array. I'm going to make it shaped so that it is 5 rows, 3 columns. And I'm going to tell it, give me the sum across the columns. And I screwed up. I meant to have it give me the sum across the rows as well, but I'll show you that in a second. Copy that. All right. So it's going to do the same values. All right. Let me change this. All right. So before we go any further, let's do 2 things. I wanted it to print I. All right. So let's start over. I asked it to make an array that's got 15 values in it. It's going to be 5 rows, 3 columns. It's going to start at 0, and it's going to go all the way up to, but not include 15. And we can see that on the screen now. If I ask it to give me the sum across the columns, do this. And tell it, give me the sum, but give me across axis 0. And in Numpy, axis 0 is always your column. It does that, and it says, all right, for the first column, if I add up 0, 3, 6, 9, and 12, I get 30. My second column, if I add up 1, 4, 7, 10, and 13, I get 35. In the last column, I get 40. What if I want to find the sum across the rows? So use axis 1. And now it gives me each row. The first row is 0, 1, and 2, gives me 3. If this was a 4-dimensional array, I would have axes 0, 1, 2, and 3. And I could tell it to sum up across any one of those axes. I used 4-dimensional, and my son didn't even respond. All right. NumPy's main library comes with a variety of universal functions you might find useful. You can solve for the square root of all the items in a matrix. You can solve for exponentiation, etc. In this case, I'm going to ask it for the sign of each value in the array. And I'm going to ask it for the square root of each value in the array. And lastly, we'll ask it for the mean. But what is the axis equal 1? What is that going to give me? It's going to give me the mean of what? 0 is columns, 1 is rows. So it'll look at each row, and it'll try and find the mean value of the row. And what is a mean value? In layman's terms, when we say mean, that's just the average. Right? So I'm going to ask it for the average across each row. And let's see what we get. It died. And the reason it died is because I'm missing a parentheses at the end. All right. So, but this is always a good learning experience. Error messages show up all the time when you're playing with Python. But that's cool, because in most cases, you don't really break anything. So if I look at this error message, I see that it says, Chalmer, you screwed up. You have a syntax error. All right, what does that mean? And it says you got this unexpected EOF, whatever an EOF is. EOF is shorthand. It stands for end of file. It was looking for a closing parentheses, and it kind of reached the end of that short snippet of code, and it didn't see that. So it said, we unexpectedly reached the end of the file while we were trying to parse. So I tell you what, I'm just going to cut and paste these guys. We'll run them all one by one. And so for the first one, I said, hey, give me the sign for each of those items in my index. And it calculates that for me. to some level of precision. Let's do the square root now. Print out the square root of each of these guys. And the square root of 2, square root of 3, square root of 4, they all come out just the way you'd expect. And then lastly, I've got to do this, but I got to put that extra parentheses at the end. And there you go. So it went through each row, and it tried to get the average value of each row. And if I call up I again, so the average value of 0, 1, and 2 is 1. The average value of 3 plus 4 plus 5 divided by 3 is 4. So it's doing all the averages just the way you'd expect. All right. What questions do we have?
In those line 32, 33, 34, it all referencing I, like the array is. And on line 34, you also include the axis. So that is basically a 2 argument then for the math operation. Where the first is the target, the second is if you want a direction.
Yes. And I'll caveat that with not every single method is going to have those 2 arguments. So for example, np sign, and I'll say, what do you want from me if I want to run this? It'll say, all right, you have, in this case, the array you want to use. I used the array that I've made called I. And then this one allows me to identify some place that I want to save this value or spit this value out. Let me find it. It will spit out an array-like object, which will be the sign of each and every element. And if I give it a place to store it, another name of a variable, it'll store it as that. So you can send it the output. But let's go look at np.mean. Notice mean can take multiple items. It can take an axis, because you want to take the average over rows or columns. It can take a data type. If you want to make sure the data type is stored as a particular type, you want it stored as an integer, stored as a float, stored as a 32-bit float, you can tell it very specifically that. If you have a place you want to send it, this out location to store it. This one clearly states that your out value could be an alternate array that you want to put the result in. Okay. That help?
Yeah.
Sweet. What other questions? You look like you have one. Think on it. You.
Okay, I got a question. When you're multiplying these arrays, right?
Sure.
Like matrix multiplication, especially with multiplying 2-dimensional arrays.
Okay.
The matrix size has to either match correctly, right? Like in regular mathematics, if you try to multiply 2 different arrays with the columns.
All right. So the question is, if you're going to do matrix multiplication, multiply matrix A times matrix B, they have to be the same size, right? I don't know. Let's find out. This is the cool part about Python.
Yeah.
You can experiment. So let's real quick make an array called A, and we'll say numpy array, and we'll give it 3 values. Whoop. Ask it for A, and it says, yes, Chalmer, you've made an array with 2 values. So let's make an array B, np.array, and we'll say 3, 4, and we'll make it a 2-dimensional array. So it'll have 2 rows, 5, 6, and make sure I have all the right brackets that I need in there, and I need all the closing parentheses. Look at B, came out the way I wanted. It's 2 rows, 2 columns. And let's see if anything cool happens or if chaos results when I try and multiply A times B.
So that did a dot product.
It ended up multiplying 1 times both of the first elements in each row. and it multiplied 2 times both of the second elements in each row, right? So what you got to figure out, and this is the part of using any sort of numerical library, is test that what you expect happens, right? And 2, if you do not understand why you're getting the result that you're getting, try and dig into the help files, etc. And I purposely ran through this exercise once you ask this question to kind of walk through this, right? The scientific libraries are very, very sophisticated, but they're made by human beings. And each human being kind of has their presumption of what is normal or what should be a default behavior. And it may not match mine or yours, right? So you got to figure it out. In many cases, if you try it out with a very small data set like I did, you can immediately kind of see the results. Whereas if you test or if you run an untested module against something that's 5,000 columns by 100,000 rows, you may not have any clue whether or not you're getting back what you expect to get or if what you get back is reasonable and normal. So it's very important as you dive into some of these libraries, read the help functions, maybe ask some questions online or look to see if other people have asked questions online and get a sense that your data is going to come back the way you want. And that's totally normal. All right. What other questions do we have?
Try B times A.
All right. B times A. It's a commutative. You got the same result. All right. Here I'm going to create an array. I'm going to use the arrange function. It's going to start at 0 and it's going to end where? What's the last character or last digit going to be?
7.
It's going to be a 7. Why?
Because it goes up 2 but doesn't include.
Goes up 2 but does not include the 8. All right. So I'm going to ask the Numpy library, run your arrange function, go up 2 but not including 8. And then once it produces that result in the background, I'm going to do the exponentiation operator and exponentiate everything by a half, which is basically going to take the square root of all the things that are in it. So C is going to be into a bunch of square rooted items. And let's go look at what C is. All right. And we see that the first item was 0, the second item was square root of 1, the next item is square root of 2, square root of 3, square root of 4. The important thing to understand about kind of that math there is that as you're building or running a function, as that function completes, you can immediately start doing mathematical operations against it. I could have multiplied that range by 2. I could have added 5 to each element of it. Here I chose to use exponentiation. So it allows you to build very sophisticated calculations, and it will automatically go against every item in the array without having to do for loops. All right. Now that I've built this thing, I want to get some data back. Maybe I don't want every single item. Maybe I don't want every single row, etc. So you can use slicing. And for those who are familiar with slicing in Python lists, you can use a single index and say, give me the 2th item out of it, give me the 3rd item, the 4th item. Or you can say, give me starting here and going up to, but not including there. So you can take portions of your list. You can do the same thing with arrays. So the first thing I'm going to ask for is I'm going to go into the array and say, give me the 2th item. And you'll hear me use phrases like that, the 1th, the 2th, the 3rd item, because Python counts weird. Where does Python start counting in lists or arrays? It starts counting at what?
0.
0. So this first element is the 0th item. This is the 1th item, the 2th item, the 3rd item. Right. So if I ask for the 2th item out of my array, what should I get back? This is the 0th, this is the 1th, this is the 2th. I should get back 1.4. Same way when we use the range, we said it goes up to but does not include. If I use this syntax with the colon, that tells me to start at a particular item and go up to but not including the 6th item. So it would start at 1.4, 1.7, so the 2th, the 3rd, the 4th, the 5th, you go up to but not including the 6th. All right. And then here, again, similar to ranges, you can say start at a number, go up to but not including the next number, and you can increment and step through. So I'm going to say start at the third number, go up to but not including the seventh item, and go in steps of 2. So let's see these 3 results come back and see if they match our expectations. The first item gave me 1.4, which is the 2th item in the list. The next item gave me 4 things, sorry. The 2th, the 3rd, the 4th, the 5th, but not including the 6th. And then the last guy, it skipped a few. Gave me the 3rd item and the 5th item. So now we know how to extract stuff from a single dimension. You can do this through multiple dimensions as well. And once you've learned to extract or identify things, you can also replace them at will. So we're going to look at both of those examples. All right. In this case, I'm going to look at starting at the 3rd item, going up to the 7th, skipping every 2nd item. And we'll replace all of those with 42. Because 42 is a good number. And sure enough, this is the 3rd item, the 5th item, does not include the 7th, so the 7th item didn't get replaced. What questions do you have? Ah, excellent question. On the web, there is a Numpy user manual, right? And there's also a place called Stack Overflow. I say that jokingly. So a couple of things. It's real easy to get to the help files for a method or for a function. Use a little question mark, use the help file. There's other parts and pieces of it that just aren't easy to define and easy to ask for help about. So the fundamentals of NumPy, to kind of get those, you need to go through a tutorial or a class or something like that. There are actually whole books written on this one library by themselves. I own like 3 of them. There's a huge amount of power in this thing, but getting to that power basically takes time, practice, and study. So let me show you at the end of this thing. I'll show you how to get to some of the documentation. Put a little parking lot here on the whiteboard, and you guys hold me accountable and make sure that I don't forget to show you those things. All right. Let's see. I'm going to make another array. It's going to be multi-dimensional. This case, it's 3 rows, 3 columns. We'll call it M. And in this case, I'm going to ask for the 0th element of this matrix. And that should give me what? Any guesses if I say give me the 0th element of this matrix? There's a vote that it might give me an 11 back. Any other thoughts what it might give back to me? Let's find out. Gives me back the first row, or the 0th row. Because remember, Python starts counting at 0. So when I say, take this matrix and give me the 0th element, it starts at its highest level. It says, this matrix has rows, and it will give me the 0th row. If I say, give me the 1th row, I can do that. If I want the 2nd row, I can get that. You say, all right, what if I want kind of an individual element? What if I want the 0th row and the 0th column? You can ask for that. And these guys are separated by commas. What did M look like again? I got to put an M in there. That helps. Awesome. All right. So that looked in the 0th row. It also looked for the 0th column in that row, and it gave me back an 11.
So this one does row column.
Hmm.
But in some of the other methods you use, the zero entry axis was 0.
Mhm.
That was the column. Is that wrong?
Yeah. Okay. So here's a nuance, right? And for those in Etherland, I've stepped away and I'm at a whiteboard. Sorry, guys. The way Python handles matrices, lists, etc. The first element of any list, if you're going to use the indexing, is always the 0th item. So in this case, I happen to have 3 larger elements buried in my matrix. So this will be the 0th item, the 1th item, the 2th item. Within inside each of those sublists, I've got another 0th item for that sublist, I've got a 1th item, and I've got a 2th item. So the question we had related to, hey, Chalmer, earlier when you said we want to look at columns, we want to look at rows, axis 0 is always columns, axis 1 is always rows. What gives? This seems like it is flipped backwards. They are actually they are flipped backwards, don't get me wrong, but it's because we're approaching the problem from 2 different ways. Python, by default, always has used the 0 index counting system to talk about elements of a larger item, like elements of a list or elements of a sublist within a larger list. Right? So in this case, back on the screen again, on line 50, when I say I have a matrix, give me the 1th item out of that matrix, it will look for the 1th sublist. And it'll give me that entire thing. And we see that it did. Gave me 21, 22, 23. If I were to go back and use a function like the mean function that allows me to question things by axis, I could say use axis 0, axis 1, axis 2. That is a completely different mechanism. And the use of the term axis comes from mathematics. When mathematicians were building mathematics and they were talking about summing across matrices and things like that, they used the term axis to say columns, rows, etc. So to defer to them, they have kind of swapped this numerical thing. And it's just a matter of kind of getting used to it more than anything. I hope that helps. Okay, so in this case, I said, all right, give me the 1th item, so look for row 1. Give me the 2th item, looks for row 2. Here I said, give me the 0th row, 0th column, sorry, line 53, 0th row, 0th column. And it found this single element 1. What if I want more than 1 item out of an individual row? That's where you can start throwing in these colons. All right, so I want the 1th row, and I want items 0 up to, but not including 2 out of that row. So those columns. Notice it only gave me the first 2 parts. It didn't give me the last one. So this syntax allows you to very precisely say, I want to have things from this row or these rows, but only from this column or these columns. And you can get very complicated with it as well. If you want the whole row, even though 3 is not inside the bounds, my list only has 3 items. I want to go up to, but not including 3. This returns all the items from that row. And again, a lot of this, I don't expect you guys to all walk home and remember all this stuff intimately. I'm going to post this file up online so you can look at all these parts. I'll also point you to the Numpy tutorial where a lot of this stuff was kind of taken from. Good coders plagiarize or something like that. The gist that I hope most of you guys will walk away from here is not that you'll walk away and remember all these things, but, oh, wow, I went there and I can do all of these things. There's all this possibility. This might be useful to my work or my job or my project. Let me dive more deeply into this thing. All right. So, let's see what else I got. Take a look at a couple other examples. We're going to print that matrix again, M, so we can see it on the screen, remind ourselves what was in it. The second item, keeping in your heads, everything in front of the first comma refers to the rows. Everything behind the comma refers to the columns. What should I get back if I ask for rows 0 up to but not including 3 and column 1? So that's how you want to be reading this in your head. Everything in front of the first comma is your rows. Everything in behind the comma is your columns. And you can specify exactly what you want out of the rows and out of the columns. Okay. So let's try and run this, see what we get. This is the matrix as a whole. I should have put spacers in between these things. That's horrible. Who thought that was a good idea? All right, let's print some of these things by themselves. All right. So this is asking for all the rows, 0 up to but not including the third row. Remember, Python starts counting 0. And all the items from the column. Column 1. So it takes a 12, it takes a 22, and it takes a 32. Did we get a personalized email address? Yeah. Sweet. All right. Are we flooding their guest? Allison told me to use guest, dude. By the way, this is my friend Stefan. He helps me run this behemoth. All right. So here's a little bit of shortcut, and this syntax works with regular lists, etc. If you just put a colon, that's a shortcut for Python to say, start at the beginning of this row and go all the way up to the end. So if you don't know how many items are in it, but you just want the whole thing, you can use a colon with nothing on either side of it. That colon with nothing on either side of it works if you put something on either side. So I can say, start at the 1th row and go all the way up to the end. Works. I can say, start at the beginning row and go all the way up to but not including the 2nd row. So that colon can help you not have to worry about typing so much stuff, especially if you don't know how long the array is. If you're like, I want to start at column 15, and I can't remember if there's 2,000 columns in this data set or there are 2,003. You don't care. You just put the colon and it automatically takes you to the end. Out of bounds. I don't know. Let's find out. All right. So we'll start at 0 and we'll go up to the 99th row. It goes up to as far as it can go. All right, which is kind of nice.
So there's no way for you to follow the prompts.
I don't know. Let's find out. Let's just say, let's ask for the 99th row. Because, dude, that's not good. There were not 99 rows. So it defaults to the, we hope this is what you really wanted answer by going up as far as it can go if you've gone too far with a slice. But if you're specifically asking for a particular row, I want row 99, then it's going to go, you're not right in the head.
Vote for dimension.
All right. So if you had 4 dimensions. All right. What if you've got this matrix and you want to flatten it out? That's what the ravel function is for. It basically, I don't know why they called it ravel. This is probably something statisticians or whatever use. I don't know, but it unravels everything and kind of flattens it out. So let's take M and let's ravel it. And it makes it basically a long single list. It eliminates each row. Okay. What if you want to change the shape? I skimmed over this one earlier. We had made a module or a matrix called U. Let me see if I can hunt it down again. It was way early. I ran a step out of turn. Probably not going to be able to find it. There we go. I made a matrix. It was all a bunch of ones, and I made sure that they came out as integers instead of floats. So I set the D type to be integers. I then took U and I multiplied each element of U by 5 and replaced U with that new result. So I should have a matrix that's 4 rows, 3 columns, and should have a bunch of 5s in it. All right. 4 rows, 3 columns, 12 items total. I'm going to tell it to change the shape. Say, you know what? Instead of 4 rows, 3 columns, I want it to be 2 rows, 6 columns. And then I'm going to ask it to print it. You can see 2 rows, 6 columns. And then I'm going to call the Numpy method to transpose it and switch it and make it 6 rows, 2 columns. Let's see what we get. There you go. So the original with its new shape, and then the transposed version. So if you have to do matrix transposition, .T solves that for you. Or if you want to do it the hard way, you can write like 12 lines of code and get it wrong the first 4 times. All right. There's a couple of ways to change the shape of a matrix. You can call up the shape attribute, and notice shape in this case is not a function. It is not followed by parentheses. It's an attribute. And you can set the shape. Say I want 2 columns or 2 rows, 6 columns. You also have some functions that are built in. There's one of them called resize, and there's one of them called reshape. Resize will change the matrix in place. So if I had a 3 by 4, it will become a 2 by 6. It basically does the exact same thing as this one is doing. Reshape, on the other hand, will create a copy of your matrix and leave your original unchanged, and you would assign the result of the reshaped matrix to like matrix V or something. All right. Something that irked me is the fact that resize, you have to give it a tuple with your number of rows and columns. But reshape, you just give it the values. You don't need to give it a tuple. That broke things several times for me. So just be aware. I had to do this whole thing, u.resize question mark to figure out why is this broken, blah, blah, blah. So just be aware. Sometimes things break. The guys who write these libraries are human. All right. Next. I'm going to create 2 new arrays. The first one is going to start at 0 and go up to, but not including 6. Right? So it'll go from 0 to 5. And I can immediately tell it to shape it in some way. I can immediately reshape this result. Because it would start out as a nice, what looks like a list. I'm going to say, you know what? I want 2 rows, I want 3 columns. So that's cool. This ability to reshape immediately with a single line of code is kind of nice. The next one, I'm going to make another array. I will then reshape it. But what's going to be in the second array? What numbers? 10, 11, 12, 13, 14, 15. And we'll stop there, right? So let's see what we get. V1 and V2. That's what we expect, 0 to 5, 10 to 15. They are 2 rows. They are 3 columns. Let's do something fun with them. I'm going to attach these together and essentially create a single matrix out of them. We're not doing multiplication. We're not adding a value to each element. We're actually going to take these 2 matrices and slam them together. I can do vertical stacking and stack V1 and V2 in that order. And now we see that V1 is on top and V2 is on the bottom. And we've made a completely new array. You can do horizontal stacking, which actually takes essentially row 1 and creates a single longer row 1. Takes row 2 and row 2 and makes a single longer row 2. All right, and I think that's the end of the show for today. Yep. I don't think it does. Yeah, it does. Let's try it. V1 dot reshape. Oh, it is 2, 3. Make it 3, 2. That works. And then it also takes a tuple inside. Now again, I don't expect you all to go home and go, wow, I know everything about Numpy. It's not that easy. I wish it was. But hopefully, from a conversation like this, you go, wow, this might solve that problem I've been banging my head against. Just looking at this long list of methods, right? There's a crazy amount of things you can do with this. You can configure your data in ways that are meaningful to you. You can remove data that's not useful. You can add new data to your record sets. And then all of the classic kind of statistical manipulations that you might want to do, whether it be correlations, covariances, and all of those crazy things, right? Standard deviations, etc. They're all built in and they all just work, provided you know how to make them work the right way. Most of these, if I run the method and I look at the help file, you see there's multiple different types of arguments to kind of change how it works. Axis was just one example of that type of, fine tuning that you can do on most of these things. So, what questions do you guys have?
Are you on the 3?
I am on Python 3.
Okay. There's a random module about something different. And then minimize. That was on a 2. So
We've had this conversation.
yes. One day.
One day. So, Rhea mentioned, Chalmer, are you using Python 3 or are you using that other thing, Python 2 something?
Use Python 2.
So the fourth dimension has just spoken and says, do not use Python 2. I'm going to caveat that. For those who are not familiar with the Python 2, Python 3 kind of conversation, Python 2 is used for many, many years and is still used widely. Python 3 is the new hotness, and it's been the new hotness for like 8 years now, something like that. I say that in a joking manner, but the important part of this is when Python 3 came out, it broke certain things, and it was not backward compatible. If I wrote Python 3 code, there were a couple of places where I could not run it in a Python 2 interpreter. Things would just break. Same way, if I wrote code in Python 2, I could not run it in a Python 3 interpreter. Things would break. The vast majority of things work just the same. If you learn one version of language, you'll be able to read and understand just about everything you do in the other versions. So you're cool there. For students who are starting out and have never done Python before, I point them at version 3 unless they have a compelling reason not to. Compelling reasons not to include everybody else in your shop uses Python 2. You should start at the same version they're all using, so that way you guys are all on the same page. There's some crazy library that you must have absolutely to make your program run, and it's only available in version 2. It's not available in 3. Stick with version 2. But those are about the only 2 real compelling reasons why I would suggest somebody stick with version 2. You have to for one important reason.
So all these things like Numpy and the other things that are going to are compatible with 3.
Just about all of the top 1,000 Python libraries have been converted over to Python 3. There's a couple of holdouts. Curse those people's souls. Sorry. There's a couple of important libraries that have not quite made that transition yet. But yeah, not on the top of my head, but I can show you. I will show you. I'll try and hunt down the Python wall of superpowers. And when I say the wall of superpowers, when the conversion to Python 3 happened, a lot of libraries were still in Python 2 land. And we had this thing, we called it the wall of shame. And it was a list of all these libraries. And they were either highlighted in red or green. Red meaning these guys had not yet made the jump and translated their code to version 3. Green meaning you were safe to use it. And we called it the wall of shame for many, many years. And then somebody did a count, maybe using Numpy, and they figured out, well, look, there are more green fields on this list than there are red fields. And we changed the name from the wall of shame to the wall of superpowers. So now if you want to have superpower, you can look on that wall and figure out which libraries are good for you. And I'll try and hunt that down and show you guys. So my friend Ria, who is using version 2 of Python for her various projects, she was looking at NumPy and looking at some things in the NumPy library, and apparently ran across something where something in the random didn't work quite the way it did on my demo. Is that what I heard? Yes, cool. What was it? Do you remember?
I just got different values. My outputs were different from your inputs. I mean, from your outputs. My outputs were different from your outputs, but we use the same inputs.
Gotcha. So, for the record, the way Python's random library works, the theory is, and it is a pseudo-random number generator, right? When you run the random function, it will spit out quote-unquote random results. They're not really random. There's an algorithm behind the scenes that says, you should get this. That algorithm starts with a seed value, and it will grab some seed. In some cases, it might grab it from something in your memory. It might grab it from some set of characteristics, like where your mouse is located on the screen, whatever. It finds a seed value, and it starts with that seed. It goes through the algorithm, and it produces random results. Your seed on your machine is quite likely going to be slightly different than my seed, so you will get different random outputs, right? If Jeff runs the random thing on his computer, he'll get different outputs. If you're in a classroom situation where you want everybody to get the same results, in most cases, you can actually set the seed that you want, maybe give it like an integer value. And if your student uses the same seed value, they should get the same random things back. That's the theory. All right. The fourth dimension had a comment?
In most cases I've seen, the internal system time is what's used as the seed.
Can be. I think depending on the interpreter of Python, they might use slightly different things. I'm not sure. Don't quote me.
I've seen the internal system time used in a lot of the things that I do.
Sweet. Awesome.
What's the number one book you recommend for NumPy?
So I bought a bunch of the books. Haven't read them yet. Why don't I show you where you go to get some documentation and some information? So we'll start there. Let me see if, let me try and figure out if I can broadcast my, nope, I don't want the camera. Screen.
It's hard to go wrong with O'Reilly books, and there is a good one, Python for Data Analysis. I don't know if it's the best one, but it's good all around.
Python for Data Analysis by Wes McKinney has a chapter, it's chapter 3, I think, that's all about NumPy. And the rest of it is about pandas, which is what the next like 6 weeks are going to be about. And so there's theoretically a way to tell it which screen to use. So let me see if I can get my browser back up. Maybe share the browser screen. And let's jump to that version of the browser. I think. All right. So NumPy. First place that I might consider going, and let me see if I can blow up some of the font size for you guys in the back. All right. One of the first places I might start is the quick start tutorial. A lot of the things we covered here are going to be there. They might use slightly different numbers, slightly different variables, but I blatantly stole most of my stuff from them. And zoom in on this. Tick tock, tick tock, tick tock. Give you a quick rundown of the table of contents, right? It's got the basics, how to create an array, how to change your shapes, how to make a copy of your array. And what that means is that in some cases, when you ask it for, give me the row and the column, it will give you what they call a view onto that row and column. It's not actually pulling them out and creating a separate entity, which you might want to do if you only want to use like 3 columns out of 5,000 columns. So they walk you through some of the principles of how do you ensure that you're getting a copy of your data. If your data has sub-entities in it that you might want to get, sometimes Python has this thing, and I'm not going to go into details, but they talk about shallow copies and deep copies. A shallow copy just says, oh, there should be a list there, and it doesn't get all the items in the list. So if somebody else changed an item in that list, because it's just getting a pointer to that, you would see those changes, etc. Again, I'm not going to go into details. Just be aware that there's a phrase called a shallow copy and a deep copy, and sometimes that can mess you up. So they walk through what that means and why this is important to you. They walk through how do you broadcast across a matrix? How do you cause things to happen across each and every element of the matrix? And they talk about that indexing and slicing that we did. They give you some tips and tricks to do that more effectively. A couple other things they walk through are like linear algebra and how you do that. There's a couple examples in here of, say you wanted to manipulate the value of your matrix. Like say you wanted to test each value. If this value is greater than 5 but less than 10, I want to change it to be some random number like -999 to kind of show that it was out of bounds. You can actually create functions and then run your function against each and every element of the array, and it will basically replace the data according to what your function tells it to do. So it kind of walks you through the fact that that capability exists. So you can be very, very specific about how you treat each and every element of your arrays. It's not just simple, well, if it's the 7th item, make it a 42. You can say, if the 7th item happens to be larger than this or smaller than this or this type of data, do something to it. So it's pretty cool. So anyway, this is a great place to go. And you can see me scrolling through. There's lots and lots and lots and lots and lots and lots of content. They've got some places where they have some warnings. They got some places where they say, go look at this elsewhere. So that's the tutorial. And go back to the top. They have a whole string of general documents about it. If you want to use it for particular things, they've got a complete manual. They have a user guide, blah, blah, blah. And for the general user guide, before they even dump you into the guide, they do, again, refer you to that quick start tutorial. And they can walk you through various specific items. If you're coming to this from the MATLAB world, they'll walk you through how you translate MATLAB into Numpy, etc. So that's that. Does that help with the documentation question that we had? Okay, we'll cross that off the list. And the wall of superpowers. Wall of superpowers, Python. There we go. All right. So these are the names of Python libraries. These are purportedly, this is just the top 200, and right now 174 of them have all been translated into Python 3.
Oh, supervisor.
Comment from the fourth dimensional peanut gallery that supervisor, you are failing us. Fabric. I'm not going to read them all out, but many of them are now green. Some of them aren't. If you want to dive into helping, you can do that.
Need to get their stuff together.
The fourth dimension says that some of them need to get their stuff together.